you, Fiery, and thank you to the organizers for the invitation to present here. It's actually really humbling to be presenting among such a distinguished list of speakers, and also to learn that I am a researcher of causality. I am identified in that way, per se. A little background on myself. So my PhD is in social psychology. My supervisor there was Matt Lieberman. Matt Lieberman is a social neuroscientist, and the focus of my work there was on causal attribution for human behavior, and that really was where I got into causality. Currently, I'm a postdoc at Caltech, working with Ralph Adolphs, and I've been continuing the program of research I started at Caltech with Ralph. And basically, with both Ralph and Matt, I've had the privilege of collecting a bunch of extensive data using a functional MRI and measuring brain activity in typically developing adults and some atypical populations as they answer why questions of various kinds, starting with human behavior, but moving forward to other domains. So, because some people maybe want to be watching TV, maybe be more entertained right now, I'm going to start off with a brief clip from a bit from Louis C.K. And you may already be familiar with it, but it's about his daughter asking him very personally why questions and how he responds to it. So,
This is my daughter the other day. She's like, Papa, why can't you go outside? Well, it's raining. Why? Well, water's coming out of the sky. Why? Because it was in a cloud. Why? Well, clouds form when there's vapor. Why? I don't know. I don't know. I don't know any more things. Those are all the things I know. Why? Because I'm stupid. Why? Because I didn't pay attention in school. Okay? I didn't listen in class. Why? Because I was high all the time. Why? Because my parents gave me no guidance. They didn't give a shit. Why? Because they looked at a car and had me, and they resented me for taking their youth. Why? Because they had bad morals. They just had no compass. Why? Because they had shitty parents. It's just like that. Why? Because fuck it, we're alone in the universe.
okay, so I just want to highlight a couple of aspects of that. One is that he's extremely fluent in kind of rifling off answers to these why questions from someone who was, I think, 4 years old at the time that she was asking these questions. And there's a lot of knowledge that he's using, prior knowledge about diverse domains, here in particular meteorology and his own behavior and the behavior of his parents and really of the world in general. And so there's a lot of domain-specific information being used here, and there's a lot of variability in the complexity and sophistication with which he's able to reason about information from these different domains. And as you can notice, he's a lot more sophisticated in thinking about the reasons why he is stupid than he is for thinking about the reason why it rains. And this is a difference that I'll return to, and really kind of the difference that was the motivation for the study that we'll get focused today. So to kind of put this in a little path diagram, we can have an attribution to a trait or a mental state such as ignorance. And we can also do this for other domains. And so we have human behavior at the top, which would be a social attribution, and we have a non-social situation on the bottom. This would be a non-social attribution. I'll use that as those terms to stand in for these two kinds of reason giving or explanation. And the basic question try to give some evidence towards today is what's the difference between these two basically processes. And give you an overview of what is to come. So I'm going to start giving you a little background on social neuroscience and the distinction between social and non-social reasoning, and the basic belief that social reasoning is somehow special or relying on distinct mechanisms. The first step to actually comparing social and non-social attribution using imaging is to make sure that you can validly and reliably isolate social attribution in the human brain. And so this first step will be giving you an overview of my early work, mostly done at UCLA, which using Y questions to define a typical network for answering Y questions. And then in the second step, I'll go into a little bit more depth on a study that compares non-social attribution to the social attribution network that I identified. Then I'll conclude and give you some caveats. All right, so some background. So just in the ways in which social and non-social explanation differ, clearly there is different stuff that are involved in the process of explanation. There's different stuff to explain. In the social world, we have human behavior, like non-human animals, robots. Non-social world, we have basically everything else, which would be things like weather patterns, natural phenomena, various sorts. We also have different ideas of what causes the stuff in the two domains. So in the social world, we have this kind of broad collection of concepts and relations that we often call theory of mind, which refers to these invisible entities called motives, beliefs, intentions, basically minds. In the non-social world, we have something very kind of different. We have natural laws. We have ideas that objects interact with each other and cause each other to move through space. And these seem like very different kinds of ideas for explaining what is happening around the world. So really, of course, they differ in content. There's no dispute over that. And the kind of real dispute comes over whether they have different processes kind of yoked to these different kinds of contexts. And early kind of neuroimaging studies in social neuroscience really kind of made the strong claim that yes, they do in fact differ in the process, and that really social reasoning very broadly considered differs in the process. For the sake of time, I'm really just going to kind of tell you what the basic conclusion of a lot of this work is. Drawing on this meta-analysis by Frank Van Overwall in 2011, looking at a lot of studies of what he calls social mentalizing here, but really is about essentially reasoning about mental states based on various kinds of descriptions of human behavior, and then comparing this to tasks that are devoid of social content involving parallel reasoning. And the basic conclusion of that study was that there were two regions, one in particular that seemed to be specifically associated with social cognition, and this was the dorsal medial frontal cortex, in particular in the left hemisphere. So the question here is, can we evaluate this evidence? How does it look? The problem with these studies is that they basically all rest on just directly contrasting the domains and thereby confounding content with process being variant. So just to give an example of this from the study, actually I quite like. I just think the inference, the ultimate conclusion of the study was, I think, wrong, probably. But a study by Mitchell and colleagues in 2005, they use a 2x2 design. They have people making impressions of social targets, other people, and of various kinds of artifacts like tools and other objects. And then they had a yoke control condition for each, just this very low-level sequencing task. And based on the data that they report, they conclude that this region specifically indexes the social cognitive aspects of impression formation. These findings underscore the extent to which social cognition relies on distinct mechanisms, and the literature is littered with these kinds of statements of specificity and exclusivity. And what you can see is that this effect shown here with the dorsal medial prefrontal cortex is based on this contrast. So comparing the person impression condition to all three other conditions. This, of course, confounds process and content. And one thing you can actually see looking at these conditions, this would be the effect size for person impression, person control. And it's the same effect size for object impression, object control. So the main effect of content, no actual interaction. So the evidence here is actually kind of weak for a domain-specific process. And the obvious conclusion that really has been kind of overlooked is that more than does not equal different than, and it could easily be explained as a single process that's just deployed differently as a function of a domain-specific expertise. So people are more familiar with, have more knowledge about, more experience with the social world, and so that could easily explain these results. Okay, so moving forward here, let me change gears to telling you how I'm going to isolate social attribution in the human brain. And as you can imagine, basically I started with using why questions, and there are two approaches I'll tell you about here, and then a big task I use for manipulating attribution. The first one is this approach where you have to generate attributions using why questions. And so you present a cue, and then you present a stimulus showing a behavior that's meaningful norm to elicit a very kind of viable attribution. Here this would be something like helping. And on other trials, you have a control question, which really kind of preempts or precludes people from making attributions. How is the person doing the behavior? Here people tend to evoke descriptions that focus on the actual concrete action itself. So something like gripping a coin or placing a coin versus there being helpful. And the method that I turn to is more experimentally controlled. It's presenting people with attributions of stimuli that have been normal, and having people evaluate them with an accept or reject decision. And you can do the same thing here, where you have basically attribute or descriptions of the stimulus that are more concrete and that kind of informs or correspond to what kind of responses people give when you ask how is the person doing. And what you have here is a very clear attentional manipulation. You just compare the evoked response to the stimuli for Y to stimuli for L, and you get this attentional manipulation that really minimizes the role of content in the contrast. So it's not content free, but it is at least content minimized, and so you can actually isolate the process. So showing you just that these are very similar networks being modulated. So this is just one of my doctoral studies looking at how this generate manipulation for emotional expressions. And what you see is a very distributed network that in the medial prefrontal cortex, the retrosplenial and precuneus, and then on the left hemisphere, the temporal parietal junction, this anterior superior sulcus area, and this area of the lower prefrontal cortex. The actual specific region names doesn't really matter here. The point to take home here is that really these two manipulations seem to be isolating a very similar set of regions and a very similar process. So at this point, I want to kind of focus attention on one of these regions. And that is a distributed network, but it appears to be centralized to dorsal and prefrontal cortex. And the reasons to state that is that this region is the most reliably observed across subjects and studies. It's very robust across different social content or targets. So different actions, emotional expressions, even kind of anthropomorphic attributions are very strongly associated with activity in this region. And there are a couple of studies that we've done and some earlier work that looked at the operating characteristics of this region and show that it shows a lot of what you would expect from a region that would have a central executive type role in a process. And so it's load dependent, so if you increase the number of amount of information people have to hold in mind in order to make a judgment, you can see parametric increasing activation, and it's also disrupted by unrelated secondary memory tasks. And then we have a couple of studies showing that you get a good relationship with actual behavior. And we also have this in lesion patients as well, people with focal lesions to this region of the brain, and showing very selective deficits on the Y task in these patients. And actually, we have patients who are lesions all over the cortex, and really this is the only region that shows a reliable impairment to performance. So this is the second step, now that in the first step I've isolated social attribution. So I'm going to go into more detail in this study. And this one uses a 2x3 factorial design, manipulating the task, so how, and the stimulus, where we have actually two different social targets, emotional expressions, and goal-directed actions. And then we have these a non-social manipulation that parallels this. And the important point here is that we can independently estimate the correlates of the process in each domain, and look to see what is similar and what is not. And this allows us to not confound the processing content. So this is just to give you a quick idea of the stimuli. People are making yes, no responses based on independently collected normative data. We know that there are foils, responses that people generally reject. So here, most people would reject that. Then for low-level control, people would reject that. People are very fast and very good at this task. We tend to get close to ceiling performance, but there is some interesting variability, as I'll show you. And then for the non-social, we have these questions regarding meteorological events and other changing seasons, so basically changes observed in nature for which people have full knowledge. And this would be the example of a how, so it's really a more factual description. And so the first question is presence of activation domain general? And what I'm showing you here is the conjunction test that takes the minimum statistic across the Weill contrast for each domain. So the regions here are really actually quite similar to what you see in the social Weill test. The only region that you really tend to see associated with social attribution and mental ed that isn't here is the cumulus, but it's actually the reason this region isn't shown is because you actually don't see it that robustly in this condition. So it kind of highlights also that the social world is actually itself a very complex and heterogeneous domain, and so maybe we shouldn't actually just be talking about the social world as one domain, because it's multiple domains for which domain general mechanism would be useful. The second question is, we do know it's an empirical fact that we see a lot of brain regions who are that show domain-specific levels of activation when you directly compare. So we can see if we have evidence of this here. Namely, what I'm showing you is the brain regions that show a stronger effect in the Weill contrast for both human behavior categories than compared to the non-social category. And all you see is this very large expanse in the dorsomedial prefrontal cortex. And so just to show you the pattern here, this is with an independently defined region of interest for this region here. And I'm just showing you percent signal change in the contrast of the effect size. And what you see is that it's a much smaller effect in the non-social condition, but it is significantly non-zero, well, zero. The given is so small and that it's really the field has a very strong belief that this isn't a domain general region. One possibility is that it can be explained away as just spontaneous social inference. So task irrelevant. You can't control when people make social inferences, so do it even when the task doesn't demand it. And so one way to look at this hypothesis is to test if dmPFC activity in the non-social domain is irrelevant or destructive to performance in that domain. And what I'm showing you here is just the weights for parameter estimates for multiple regression. Looking at the activation of this region in the social domain and the social Weill and in non-social Weill as simultaneous predictors of accuracy in each domain, accuracy in the Y condition. And so what you see for social is what you would expect if this region is involved in social attribution. It is associated with performance, but in social attribution, but only for the level of activation in the social domain. And what you see for non-social is the opposite. You get this nice double dissociation. When you activate this region in the non-social domain, you are better in the non-social domain. That has nothing to do with how you are in the social domain. We can also get at this another way. we can look at individual differences that are related to this dispositional motivation to understand other people's behavior, with the idea being that these people would be the most likely to make these automatic inferences when it's not relevant to the task. And just looking, the actual names of the scales at this point aren't important, as these are just traits that really correspond to people's tendency to be interested in and curious about other people and behavior. And this is the same kind of approach. These two levels of activation across the domains are simultaneous predictors. And what you see is, as you expect, this is a strong predictor of these traits for the non-social activations, but not in non-social. And so, to answer this question, I don't think so. It doesn't look like it. So, to conclude, the evidence that I presented seems to indicate that behavior transformation indeed is centrally based in a domain general process, one that can be flexibly applied to other domains. And there's some possibilities for what it is. Very unclear now, but there's quite a lot of work on just semantic memory and semantic memory use that also implicates this region. And showed you that there was an enhanced responsiveness region for explaining behavior, and that the degree of enhancement was associated with these domain-specific traits. And so my current account of what is happening here is that this is a domain general process that is operating on domain-specific contents, and that this operation is affected by a level of domain-specific activities, namely that people have more experience and more interest in social role, and so they use it more in that domain than others. Caveats real quick. I just want to clarify the scope. Partly academic claims that when studying social cognition in general, or even theory of mind in general, I tend to be very suspicious of, because it's a very complex phenomena that can be operation defined in many ways. So I'm very much like, look at what the actual task here, answering and generating responses to why questions, and evaluating answers to why questions. That would be kind of the scope here. And there's other domains in which there actually may be domain-specific processes still. And then, of course, this is about ontogeny. This really doesn't speak us in any clear way about questions of why this process may evolve in the first place. It's really just about what can we do with it now in adult. And but I do think it is quite consistent with the idea that it evolved because of the increasing complexity of primary social structures in our evolutionary past. And really, as I mentioned before, the social domain is so freaking diverse and complex that really it would be very beneficial to have a process that is flexible if we were going to try to deal with the causality in the domain. So I will end by thanking people by listing their names.